new chapter. This is chapter 5, talking about electricity and magnetism. This is lesson 66, and we're going to be covering pages 94 to 97. We're going to be talking about electricity first, and then later in the future lessons, we're going to be talking about magnetism. But something you need to remember when we talk about these two subjects is that they're connected or related. All right, so let's go ahead and get started. And I have a special little project that I'm going to show you to help you understand. Okay, page 94. It says, think about some of the things you do every morning. Maybe you wake up to the sound of an alarm or radio. You probably turn on a light. Perhaps you use a toaster as you fix your breakfast. You might listen to a weather report on the radio or television. All these things use electricity. Because electricity is most likely part of our daily routines, it is an important topic to study. God wants Christians to honor Him in all areas of their lives, including their use of electricity. And think about it. When you woke up, now I'm trying to remember waking up this morning, and my alarm went off, and through the night, we have the air conditioning running if it's warm, or the heater. And then, of course, we have the fan blowing to circulate the air. So those two things are using electricity. My alarm, that's 3. And, of course, I wake up and I turn on the light. That's 4 things. And then I might go make some breakfast. I made some eggs this morning that required my electric stove. That's 5. The refrigerator to keep my food cold. That's 6. Then, of course, I went to the bathroom and did things in the bathroom, like take a shower, brush my teeth. Of course, I got to turn on the light so I can see what I'm doing. All of these things require electricity, and we're going to talk about how we can utilize that electricity. It doesn't just magically appear when we just flip a switch. Something had to create that. So let's keep going and talk about how electricity is formed. Electricity is a form or a kind of energy that involves the flow or moving of electric charges. It provides a force, and we learned that from last chapter, a push or pull, that can make things move. Many items use electricity to do work. Some things may not seem to have electricity, but everything contains small amounts of it. These particles of electricity are called electric charges. Now, we're not going to learn about this in this chapter, but every part of matter, everything that has matter, of course, everything that has matter has these little particles, okay? And we're going to talk about them later when you're in the 5th grade and in 6th grade. They're called atoms, but right now we're just going to call them particles. And each atom has different charges. They have a positive and a negative charge. And we're going to talk about that in just a moment. So all matter is made of these particles, and those particles have little bits of electricity or electric charges, positive and negative charges. And we'll talk more about how they move in just a moment. All matter is made up of small particles. These particles are so tiny that you cannot see them. So you can make a note in your book. They're called atoms. Even you are made up of these tiny particles. Each particle of matter has electric charges. Did you know you have electricity moving through your body? Well, if you feel pain or heat, that's actually electricity moving from your brain to your skin to feel these different things. Also, when you are seeing something, it moves through your eye as electrical charges. How your ear hears. Sound vibrations are turned into electrical charges that send a signal to your brain. Your body is full of electricity. Your heart also beats because of small amounts of electricity. But all of the little particles that make our body, called atoms, each atom has its own electricity or electric charges. Let's continue on. Even you are made of these particles. Each particle has electric charges. An electric charge can be positive, the little plus, or a negative, a minus sign. A neutral object has the same number of positive charges as negative charges. Now, you might be thinking, well, if I have electricity moving through my body, how come we don't electrocute each other when we touch each other? It's because most matter, most things that we touch are balanced, meaning the positive charges and negative charges are equal or the same. And if they're equal, the energy is not going to move. So we don't have to worry about touching everything and sending an electrical charge to somebody. Why? Because most of the matter in our body is balanced, or most of the matter that we touch is balanced. Let's keep going. Positive charges do not move. Which ones do not move? Positive, or the plus sign. But negative charges can move from object to object. Rubbing an object causes it to gain, or to get, or lose negative charges. When you rub your hair with a balloon, your hair loses negative charges. The balloon gains the negative charges from your hair. Okay, so I have a balloon here. I don't know if you can see it. I'll back up just a little bit. If I rub this on my head, this balloon, can you see what the hair is doing? It's sticking to the balloon, because what happened is that negative charges, when I was rubbing it together, went from my hair to the balloon. Okay, so now it's unbalanced. All right, and we'll learn more a little bit later in this lesson why the hair sticks to the balloon. Okay, because your hair lost negative charges, it is no longer neutral, meaning the charges are not the same anymore. There are more positive charges than negative charges. It has now more positive charges than negative charges. This means your hair is now positively charged, meaning more positive charges. The balloon is no longer neutral. It gained negative charges. It is now has more negative charges than positive charges. The balloon is now negatively charged. Negative charges can move anytime two objects rub together or touch each other. Negative charges can move when you comb your hair with a plastic comb. They can also move when you walk across the carpet. Now, this can be a little fun, but this might make somebody a little bit upset, but especially during the winter time, when there's less moisture in the air, this happens better. If you put your socks on and you rub your socks across the carpet, you can zap your brother or sister with little electric charges. The summertime, it doesn't happen as frequently because it's more moisture in the air. But especially in the wintertime, you can zap your brother or sister. But don't tell Mom I said that. Anyway, so you're wondering maybe why did my hairs touch or stick to the balloon? Well, as I rubbed the balloon on my head, negative charges from my hair transferred or moved to the balloon. So now my hair has more positive charges, and we'll call them protons later on when we talk about atoms. There are more positive charges on my hair, so I'm positively charged on my head. Then the balloon has more negative charges, or it is negatively charged. So now these different items are not balanced. Now when you have opposite charges, what happens is they attract, and we're going to learn about that a little bit later. So opposite charges attract or come together. So positive here, negative here, it caused my hair to stick to the balloon. All right, let's continue on. Static electricity. There's two kinds of electricity we're going to talk about in this chapter. Static and current electricity. Static is the first one, then current electricity. Let's talk about static. When you walk across the carpet, your shoes collect negative charges. These charges build up on your body, and when you touch a doorknob or your brother or sister, the negative charges jump from your hand to the doorknob. This jump can cause a small spark and mild shock. The spark and shock are caused by static electricity. Static electricity occurs or happens when electrical charges build up on the surface of an object. This happens more when the air is cold and dry, like I mentioned in the winter time. So this first kind of electricity, this is static electricity. And static electricity happens maybe when two objects rub together. For instance, lightning, that's an example of static electricity. What happens is the clouds are rubbing together and moving electrons from one cloud to another. And when these electrons build up on the surface, and then the ground is positively charged, what happens? It joins together and makes a very quick jolt of electricity. And it stops when everything is balanced. So if you're rubbing something together and you get static electricity, when those charges are balanced, when they jump from one item to the other, after they're balanced, they no longer stick together anymore. Okay? This only happens when you have opposite charges. So like one object is positively charged, one object is negatively charged. The objects come together. So let's keep going. The electric charges on an object cause electric force, or a push or pull. Sometimes the charges repel or push away from each other. At other times, the charges attract or pull toward each other. So these two words, repel and attract. Repel means to push away. And you'll see up here in the picture in your book, there are two charges that are the same, positive and positive. They push away from each other, very similar to what a magnet does. If you put two poles together, like North Pole and North Pole, if you try to push them together, they'll push away from each other. They repel. But if they're opposite charges, just like with a magnet, if you switch the one from north to south, what will happen? Those magnets will stick together, okay? Because opposite charges attract. So same here with electricity. If you have a positive and negative charge, they will come together. But negative and negative, repel. Positive, positive, repel. But opposite charges, they attract. Let's keep going. Objects with the same charge repel each other. When you comb your hair, the comb collects negative charges. The hair loses negative charges to the comb and becomes positively charged. Each positively charged hair repels the other positively charged hair. This repelling is what makes your hair move apart. The negatively charged comb attracts the positively charged hairs. This attraction is what makes the hair move toward the brush or comb. If you rub two balloons with a piece of wool, each balloon gains negative charges. Then when you try to bring the balloons close together, they will repel each other. Okay, so like I demonstrated before, sometimes, and this again works better with cooler weather, but if you rub this enough, and I do have hairspray in my hair, so it might not work as well. Okay, so it is sticking to the balloon, but if I pull away, can you see it sticking up? All right. This is happening because my hair is positively charged, and there's lots of positive charges in there that are pushing away from each other. Now I can kind of comb that down. Okay, but also, now what is happening? I have an attraction here. So down here, they're pushing the positive charges away from each other. Why? There's too many positive charges here. But here, I have negative charges up here. So they're opposite charges, and so now they stick together. Positive charges push my hair up, okay, and away from each other. But the negative charges attract the positive charges, okay? Let's keep going. Objects with opposite charges attract each other. The results of this can sometimes be seen when clothes come out of a dryer. The clothes touch each other as they tumble in the dryer. Some pieces of clothing lose negative charges and become positively charged. Other clothes gain negative charges and become negatively charged. The clothes with opposite charges stick to each other. Now, I'm not sure if you have a dryer at home. I do not have a dryer. I hang my clothes up to dry. But if you have a dryer at home, you can see this happening, especially if you don't put a dryer sheet or fabric softener in your clothes. That reduces that friction that causes them to stick together. But as these clothes are in the dryer and they tumble and they tumble and they tumble, they're rubbing against each other. Well, when you rub two objects together, it's possible that negative charges move from one object to another. So sometimes when you pull something out, a lot of times, like in your picture, you get socks that are stuck to other objects. Why? Because one is positively charged and one is negatively charged. Let's keep going. As you pull apart the clothes that are full of static electricity, you may feel tiny shocks. You may even see little sparks. These effects happen as the negative charge jump from the negatively charged clothes to the positively charged ones. Once this occurs or happens, the clothing has the same number of positive and negative charges and is neutral. So even though static electricity is electricity, it's not useful, because as soon as those negative charges finish jumping to the other objects and balance each other, then the electricity stops. So static electricity is not useful, but it is still electricity. I have a little object that I want to show you that can tell you if there's static electricity on an object or not, okay? So here I have a piece of clay. I'm going to back up so you can see it, all right? Okay, I'm going to put that here, and I have a straw. And what I'm creating is what is called an electroscope. Now, there are fancy equipment that can tell you how much static electricity is on an object, and sometimes that's really important to know how much. But in this case, we're just showing whether or not electricity is here, or static electricity is on an object. So if you take a piece of clay, and you can use a piece of tissue paper, which I didn't have any, but you can also use a piece of foil, okay? All right, and you stick it in on a straw that's bendable. That way you can see that the papers are hanging over. It's very visible to see the paper hanging on the straw. And then if you just put it in a piece of clay, that helps the straw to stand up. Okay, so I'm going to bring my balloon back out, and what I'm going to do is I'm going to rub it on my head one more time, and we're going to hopefully see these pieces of tinfoil move. That will show you that there is static electricity. Can you see it? See it moved? All right. All right. So that means that this metal foil is positively charged and the balloon is negatively charged, and therefore they attract. So therefore we can detect, yes, there is static electricity on this object, okay, or electrical charges. Can you see this move? Do a little bit more so you can see it one more time. I'm going to get up a little closer so you can see. See? That shows the presence of static electricity. I hope you had fun in this lesson, and I'll see you next time.